Welcome back. So that was overlapping subproblems. Next, we're talking about the second feature that needs to be present in a given problem in order for us to use dynamic programming to speed it up. Okay, so that thing is optimal substructure. Okay, let's take a deep breath. Optimal substructure. So a problem is said to have optimal substructure if the optimal solution for a bigger problem can be constructed from the optimal solutions for its subproblems. So that's the case for these Fibonacci numbers, definitely. We find Fibonacci of 5, the optimal solution for Fibonacci of 5 also depends on the best solution for Fibonacci of 4 and 3. That's the very definition of it. But here's another example that might make it clearer. Talking about the shortest path between vertices on a graph. So here's a simple graph where we have A, B, E, C, and D. And if we wanted to find the shortest path, the optimal solution from A to D, there are these weights along the edges, and that shortest path happens to be A, B, C, D. Here to here to here to there. So we don't go through E at all because that's longer. So the shortest path to D from A, one more time, A, B, C, D. And we would say that this problem has optimal substructure because we can construct the optimal solution from A to D from the subproblems and their optimal solutions. So when I say subproblems, I mean the shortest path from A to C, for example. Well, the shortest path from A to C is A, B, C. Or the shortest path from A to B is going to be A to B. So we can take those subproblems, find the shortest way to get to B from A, the shortest way to get to C, A, B, C, and then that also gives us the shortest path to D. So the point is, if instead the shortest path somehow was A, B, E, C, D, then the shortest way to get to C would also have to be A, B, E, C. Does that make sense? So when we're talking about the shortest path going from a start to an end, whatever that path is, any other point along that path also is going to be the shortest path from the start to that point. So from A, B, C to D, that includes the shortest path to C and the shortest path to B. And if it didn't, it would no longer be the shortest path. So that exhibits optimal substructure. Now here's an example that doesn't. So it's another graph. Oh, kind of messed up my arrows there. Sorry about that. And this one's different. We're looking for the longest path, this longest simple path. And what simple means is that there's no repeating of a vertex. Because if we did allow repetition, let's say I'm trying to go from A to D, we could just do A, B over and over to the end of time and have an infinitely long path, but with no repetition. So if we're trying to find the longest path from A to C, it's A, B, C, right? That's the only way to get there. If we're trying to find the longest path from C to D, it's C, B, D, okay? So if we're trying to find the longest path from A to D, can we just add those together? Is it A, B, C, B, D? A, B, C, B, D. And the answer is no, of course, because we can't repeat. We can't go back to B. The longest path, in fact, is A, B, D. I know it might be a little confusing, but just think of it this way. We're going from A to C, we find the longest path. We go from C to D. That's also the longest path. So if this followed optimal, if it had optimal substructure, we could combine those and just say, oh, okay, well, the optimal longest solution to D from A is A, B, C, C, B, D. But that's not the case because we can't repeat. So longest path, finding the longest path, does not exhibit an optimal substructure. I hope that makes sense. Here's one more example from the real world. If we're trying to find the cheapest possible flights using some sort of web search, it seems like that this should exhibit optimal substructure, but it doesn't. So if I'm trying to go from San Francisco to Fairbanks, Alaska, that's exhibited by this. I did a search. This is real. The cheapest way to get there for a given day, I forget what date I plugged in, was to go from San Francisco to Seattle to Fairbanks. So stop in Seattle. It was $185 for 2 flights. So if this exhibited optimal substructure, then the shortest or the cheapest way to get to Seattle should be just SFO to Seattle. That should be the same flight. But in fact, the cheapest flight from SFO to Seattle was not SFO direct to Seattle like we had here. There was actually another stop through Portland. That was the cheapest thing I could find. It was only $109 if we stopped in Portland. So it seems like logically that this should exhibit optimal substructure, because the cheapest way to get to Fairbanks should include the cheapest way to get to Seattle. But because of the way that airlines sell their tickets, the way that things are bundled together and incentivized, that was not the case. The cheapest way was actually to stop through Portland. Then you would think, okay, well, isn't the cheapest thing I could book from SFO, then to stop in Portland, then to Seattle, then to Fairbanks? And that might be the case, but airlines aren't selling that. You would have to bundle that together yourself and make it work, if that makes any sense. I don't know how much experience everyone has trying to buy tickets and price engines and all of that, but it's kind of wonky. But hopefully this makes it clear. When I say optimal substructure, this does not exhibit it. The optimal solution, which in this case is the cheapest price to get from San Francisco to Fairbanks, doesn't actually include the cheapest way to get from San Francisco to Seattle, even though we go through Seattle. Anyway, so that's optimal substructure. Just to recap, we're looking for a problem where its solution, the optimal solution, whatever that means, can be constructed from the optimal solution of its sub-problems. And if you're struggling with this bit, I recommend rewatching this video, but also doing some research online. I've definitely seen some students have a bit of a mental hurdle understanding this part. But I tried my best to come up with some good examples. It's kind of tough. If you Google it, a lot of the common examples are very complicated, advanced math, and it's tough to understand. So these are the simplest things I could come up with. Anyway, that's optimal substructure.